Hello, welcome to this tutorial video about physical layer security, aka PLS. My name is Nicholas Casas, and this is for EEE 185. So first and foremost, I want to discuss what actually is physical layer security. Um, to begin with, you have your physical attributes and you have your computational attributes, so your software, your malware, and in that middle spectrum, there's a gray area, and that's what physical security tries to encompass. Uh, the physical level layer security is utilized to complement the computational software. PLS is based and derived by Shannon secrecy model. We'll discuss that in more detail in a few moments. I just wanted to mention that this whole spectrum of security encompasses many different disciplines. And so to define PLS, you could simply say that there's physical attributes, which low probability of interception LPI is guaranteed via properties of modulation signals and channels without the use of source data encryption. In other words, you don't need software computational security mechanisms. So to dive right into it, I want to introduce the Shannon secrecy model. It was first derived by Claude Shannon, and he introduced it from the standpoint of the study of confidentiality in information theory. The objective in his model was to successfully and reliably transmit and receive information or messages, all while having a third party eavesdropper not be able to attain that information that was being transmitted or received. To achieve this, uh, both the transmitter and the receiver parties had a code word, a key that enabled them to decode and encode their messages at their leisure, at their free will. This is considered as an overview abstraction, just as a general theory or an idea, just because there's a lot of caveats that begin to arise. Uh, One example, I guess you could state is the Enigma machine that was derived in World War II. Germany had explicitly exchanged information back and forth, transmitted and received amongst each other, and they did it with a key card or different words to symbolize or encode and decode. Thankfully, we were able to transmit or intercept those keywords, but if you think about an enigma, that's generally what this idea encompasses of the Shannon secrecy model. So to convey the idea of security and its and what potential consequences are, I have this diagram that I would like to show you all. So we have an eavesdropper, correct? And with that, there's a fake server and a fake device. And so this is an applicable example in which there's tangible items, there's physical tangible items that can influence and disrupt the servers, networks, and devices themselves that are legitimately there for a purpose or a functionality. Uh, so in this particular case, we have a fake server that could disrupt or trigger certain uh, events, such as a dam break or, an electrical outage. And the fake device could also disrupt measurements and have them read false readings, all while the eavesdropper is picking up on this information and making use of it. So, as I've mentioned, the Shannon models, it's more of a pioneer model, in other words. So, what we have here is two basic and simple uh, models of physical layer security in which they're improved and actually proven to be better than the Shannon model. So the first one that I want to discuss is the Weiner model, also known as a wiretap channel. So one thing to note is that these models are solely for receiving and transmitting and how an eavesdropper, a third party, can intercept or not. And these two here in particular demonstrate the the technicalities and difficulty of a third party being able to attain information. So here in the wiretap channel model, the key is to attain a perfect secret, you know, transmit with confidence, and it's attained if and only if a third party eavesdropper has noise, and that noise is more than what you would receive of the noise on the receiver's end. So Weiner proposed that the channel quality and wiretap codes uh, would serve paramount since guarantee of a noisy third party may not be fulfilled. So in other words, there's no guarantee that the third party that's eavesdropping, trying to intercept the information being sent or received, that they're going to have more noise than what the channel is itself. So having both channel quality and those codes will serve even a greater benefit as it's just opposed to just the simple key card or code. The second model that I want to discuss is the channel model for secret key generation. So this is just an extension of the Weiner model, and it just states that information to be transmitted and received publicly. So the key here is that it's public, and so it allows for uh, information that can be conceived as an opportunity for an eavesdropper to use until they find out that the transmitter and receiver have been sending out information on authenticated channels. So, um, you've heard me talk about, what physical layer security is and why where's different models and how they're implemented. I just want to discuss briefly the relevancy behind everything. Um, so first and foremost, we transmit information every day through our text messages, emails, uh, and understanding the importance of having secure channels when we transmit and receive gives us a more peace of mind. This also provides a perspective of the consequences and what is at stake, the consequences of malicious intent, and the complexity of the framework in which we are using it provides users the best experience possible. I just want to say thank you for listening, and here are my references.